Hello everyone, welcome to the video. In this section, this video, we're looking at section 2.2, where we're going to be using inductive and deductive reasoning. So, our main goal here is to figure out how we can use reasoning to help us solve problems. So, in order for us to um, make a conclusion using inductive reasoning, we have to make a conjecture. So, a conjecture is an unproven statement based on observation. So, it's stuff that you see, stuff that kind of like past experiences and stuff like that, and it's not a guess, but it's very it's a sort of a guess with a little bit of background information. A lot of times it's being able to discover what patterns are and create conclusions in those general cases. So here it says they're asking you to describe how you'd sketch the fourth figure in the pattern. So if you look here, looks like there's two parts to figure one, four parts to figure two, and six parts to figure three. So I'm led to believe for figure four that it's going to be a circle that's going to have eight. So one. All right, so we got eight. One, two, three, four, five, six, seven, eight. And it looks like there's a shaded portion, and it looks like it's the kind of the upper left. So I would say that this one would get the shading. So through my observation, I would say that is my fourth figure. All right, so here, kind of the same thing. They want you to sketch the patterns. I would recommend you to give it a try. If you need help, leave a comment but down below. I am more than happy to um, work out these problems if you need it. In this example, it says numbers such as 3, 4, and 5 are called consecutive integers. It says a test, make a test, a conjecture about the sum of any three consecutive integers. So, well, let's just use those three numbers that they gave us. So if we took the sum, which is addition, so 3 plus 4 plus 5, we'd get a result of 12. So let's take another one. Let's say I go 7 plus 8 plus 9. The result of that is going to be 24. And let's say if I go another one, let's go 14 plus 15 plus 16. And the result of this is going to be 45. Now, what kind of pattern can we say, or what kind of conjecture can we make about three consecutive um, integers? Well, what I notice is if you took the middle number in these sums and multiplied it by 3, you would get the results of those sums of consecutive integers, because 4 times 3 is 12, 8 times 3 is 24, and 15 times 3 is 45. So my conjecture would be taking the middle number of the consecutive integers, multiply it by 3, you would get your result. So that would be my conjecture. Now, for the most part, you're going to show conjectures that you created that are going to be true. So you must show that it is true for all cases. All right. In order to show that it is true in all cases, usually you got to denote by a variable. Now, there are some instances that a conjecture is false, and how to determine if a conjecture is false is by providing at least one counterexample. If you can provide a counterexample, then you can say that the conjecture is false. The thing is, for a conjecture to be true, you have to make sure it's true in all cases. That's why it's always harder uh, to find a true conjecture. It's always easier to find a false one because you just have to find one example where it's not true. So in this problem here, it says a student makes the following conjecture about the sum of two numbers. They say find a counterexample to disprove the student's conjecture. So the conjecture is the sum of two numbers is always more than the greater number. So let's just say I try to give you a true statement. All right, so there's like, oh, let's say 2 plus 3 equals 5. Well, the largest number here is 3 and 5 is greater than 3, so that would make it a true statement. Now to provide a counterexample for this, which would make it false, is let's say you would put something like negative 2 plus negative 3 equals a negative 5. Well, the larger number between these two is negative 2, and negative 2 is larger than negative 5 in this instance, which would make this conjecture not true, so that's why we say that is false. So inductive reasoning is being able to discover patterns and such. Deductive reasoning with a D is reasonings that uses facts, definitions, acceptable properties, and the laws of logic to make their argument. All right. It's different because inductive reasoning is those conjectures where you're trying to find patterns and then you're using specific examples to make your conclusion true. So there's two different types of laws of logic. You can use law of detachment, which is if the hypotenuse of a true conditional statement is true, then the conclusion is also true. You can use the law of syllogism, which is you're essentially going to have two conditional statements. And one of the things that you have to keep in mind is if you look here, I have a Q and a Q. One's a conclusion, one's a hypothesis. So as long as you have a statement that is a conclusion in one conditional statement and is a hypothesis in another conditional statement, you can use the law of syllogism to create this third conclusion. So they're saying here, if you have hypotenuse P, then conclusion Q. If hypotenuse Q, then conclusion R, then you can say the hypotenuse P in the first statement is the same as conclusion R. But there are other variations that you can make, uh, and I'll give you examples of how those are created. In this example, it says if two segments have the same length, then they are congruent. So this is the conditional statement right here. If and then. You know that BC is equal to XY. So that's the same length. That's what the same length comes in. And they want you to use the law of detachment and which statement you make. So since they've already given you something about the length, now we're going to use something about them being congruent. So if the segments are the same length, we can say that they're congruent. So we can now also say that BC is congruent to XY because the law of detachment allows us to make that conclusion. Here it says, if possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So here it says if x squared is greater than 25, then x squared is greater than 20. if x squared is greater than 5, then x squared is greater than 25. So if you noticed that x squared is greater than 25, this is the hypotenuse in this statement. This is the conclusion in this statement. So this is where it ties in, where we can use the law of syllogism. All right. In the example, they had like the conclusion of the first one is the hypothesis in the second one, but here the hypothesis in the first one is the conclusion in the second. So what we can now say for the third statement, because we have this correlation here of hypotenuse conclusion, I can say now that if x is greater than 5, then I can say that x squared is greater than 20 because the law of syllogism allows us to make that conclusion. Here, it says if a polygon is regular, then all angles in the interior of the polygon are congruent. If the polygon is regular, then all of its sides are congruent. Here's the problem with this one. The ones that are the same are if the polygon is regular and if the polygon is regular. Since it's written first in the conditional statement, this is the hypothesis and this is also the hypothesis. It would have to be one of those statements we talked about where polygon is regular would have to be a conclusion for the law of syllogism to work, so it's not possible. Here it says, what conclusion can you make about the product of an even integer and any other integer? So a lot of times when you want to use deductive reasons, you got to use variables, but let's look at some inductive reasoning. Let's first off, let's make a conjecture. So I'm going to pick an integer, let's say 2, and any other one, let's say 4. So 2 times, I'm sorry, I said 4, let's make it 4. 2 times 4 gives me a result of 8. Let's do 6 times 3 that equals 18. Let's say I go 8 times, let's go 6, and that gives me 48. So I have even number, even number, even number, and I have any integer on this side. It could be even or odd. The result of this was an even number, an even number, an even number. So I can, right now, my guess is that they're all going to be even. So using deductive reasoning, we got to use letters. So in this case, I'm going to let m and n be any integer, whether that's even or odd. All right. I'm going to say that 2m is even. Okay. So 2 times whatever integer will give me an even number. 2 times 2 is 4. 2 times 3 is 6. 2 times whatever, it's going to give me an even number. So now what I'm going to say is 2m times n represents the product of an even and any integer. Okay. So basically I can go like this. So 2m is the even number, n is any integer. All right, now what I'm going to do is I'm going to say I'm going to go 2 times about the quantity of m times n. So I can do that because of the associative property of multiplication, and that's an acceptable property using deductive reasoning. And whatever the product of that is multiplied by 2 is going to be an even number. So that's where I can say that the product of an even and any integer equals an even. So this is kind of the steps that you'd have to take from that. All right, so here they're asking you to decide whether inductive reasoning or deductive reasoning is used to reach the conclusion, and they want us to explain your answer. So for part A, it says each time Monica kicks a ball in the air, it returns to the ground. So the next time Monica kicks a ball in the air, it will return to the ground. So they're looking into the future, for instance. So this is going to be inductive reasoning. Reason for that is they're making through observation. Um, they noticed she kicked the ball the first time and went to the ground. They're going to assume that the ball will hit the ground again through the observation. For part B, it says all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet's parrot is not a reptile. So this is deductive reasoning. And the reason for that is they are using those law of logics. They're talking about the facts of animals. This parrot is not cold-blooded. Reptiles are. So if it's not cold-blooded, they use that conclusion that the parrot is not a reptile. And that is being able to use inductive and deductive reasoning. Hope this helps. Till next time.